As you might suspect, division in assembly language is the opposite of multiplication. So we're going to take some of what we've already covered about multiplication and apply it to division. This video covers division using both unsigned and signed integers. The unsigned divide instruction looks real similar to its multiply counterpart. It has explicit operands and implied operands. Notice that the implied operands are actually pairs of registers. AX is treated as the AH and AL pair. And also take note that the explicit operands are the divisors, the values that we're going to be dividing into the implied operands. So if I have divide BL, the assembler knows that I mean divide the 16-bit AX register by the 8-bit BL register. And divide CX, the assembler knows that I mean divide the 32-bit DX-AX register pair by the 16-bit CX register. And divide N1 means divide the 64-bit EDX-EAX register pair by the 32-bit N1 variable. Here's the same information in table form. Make sure you see that all of the dividends are implied operands, and that all of the divisors are explicit operands and are either registers or variables. In other words, there are no immediate operands. An important thing to keep in mind when we're dividing is that you have to set up the register pairs before you can divide. What that means is we have to load up the values into, for instance, DX and AX ahead of time. So if I want to perform an 8-bit divide to find out, say, how many times 23 will go into 100, I put 100 into the AL register and 0 into the AH register. Then I use an 8-bit variable or an 8-bit register to hold the 23 divisor. Here's an example. I define the variables I need. Then I set up AL and AH as the dividend. Now, dividend is a fancy math word that means the number we're dividing. Next, I use the integer divide instruction and use the N1 variable as the divisor. Once that instruction executes, the quotient will be in the AL register and the remainder will be in the AH register. Now, what that looks like is kind of like when you were in 3rd grade and doing division. It would look like this, in other words. So the quotient from AL would be stored here, and the remainder from AH would be stored here. There are a couple of important points to remember. First, remember the quotient will always be in the lowest member of the register pair. That means either AL, AX, or EAX. Next, the register pair will always be twice the size of the divisor. So if you want to divide by an 8-bit number, the register pair would be 16 bits big. Last, the divisor, quotient, and remainder will always be the same size. Since you're going to be doing division of 32 bits more often than anything else, let's look at an example of that. For this 32-bit divide, I want to divide 595,000 by 375. I first define the variables I'll need. Please notice they're 32-bit variables. Then I set up EAX as the dividend. I clear out the EDX register since it's the high register of the pair. The zeros in all of the bits of EDX indicate that the dividend is either positive or unsigned. Then I load up the EBX register with the divisor. Now all three of those registers are 32 bits. Please see that. If I were using a variable divisor, it would have to be 32 bits, just like the EBX register is now. Next, I use the integer divide instruction using the EBX register as the divisor. Once that instruction executes, the quotient will be in the 32-bit EAX register, and the remainder will be in the 32-bit EDX register. Let's go back to 3rd grade. The division would look like this. So the quotient from EAX would be stored here, and the remainder from EDX would be stored here. Got a question for you. How would signed division change anything? We need some sort of sign. Okay, here's a very important rule. The dividend, in other words, the number that's going to be divided, will always be a pair of registers. The lower register of that pair will be the number you really want to divide, and the higher register of the pair will just either be all zeros or all Fs, depending on whether the lower register is unsigned, signed, or positive. So here's what you do. You load the number you're going to divide into the lower register. Then you extend its sign to the higher register. When we were working with just unsigned integers, we just stuck a 0 in the higher register because that indicated that either the lower register was positive or that it was unsigned. But with signed division, there are 3 instructions that come in real handy for this purpose. If the number in the lower register of the pair is negative, then we want the higher register to contain all Fs. This chart should help. Again, let's pick the one you're going to use the most. That is 32-bit division. You load the number you want to divide into the EAX register, and then you use this instruction right here to extend the sign into the EDX register. Let's see what that looks like in code. All right, here I want to divide negative 25,000 by 475. I first define my variables, and then I get to the code section. The first thing I do is load the EAX register with num1, which is the negative 25,000. The next thing I do is to extend the EAX register's sign to the EDX register. Now we're dealing with signed integers, which means if EAX contains a positive number, then EDX should contain all zeros. But on the other hand, if EAX contains a negative value, which it does in this case, then EDX should contain all Fs. So I do my signed division instruction, which places the quotient in the EAX register and the remainder in the EDX register. The next thing, I store the EAX register into the quotient variable. Since we're dividing a negative by a positive, this quotient's going to be negative. Then I store the EDX register into the remainder variable. Notice it has a negative sign also. It wouldn't hurt to take a look at this in Visual Studio. Here's the same program in Visual Studio. We're all set to store the negative 25,000 dividend into EAX. Let's start stepping through the code. First, the negative 25,000 goes into the EAX register because that's what we really want to divide. Now look at the high order bits in the EAX register. They're all Fs, which indicate that this value is negative. Then we extend the Fs into the EDX register so that the entire EDX register matches the high order bit of the EAX register. The next step is to use the signed integer division instruction. After that, look again at EAX and EDX. EAX is holding a negative number that represents the quotient, while EDX is holding a negative number that represents the remainder. So let's store the quotient into the quotient variable. You can see that happen in the memory 1 display and also in the watch window. Then we'll store the remainder that's in EDX into the remainder variable, and again, you can see that happen in the memory 1 window and also in the watch window. Now the text mentions that you have to watch out for something called divide overflow. That occurs when the division tries to store too large of a quotient into the lower register of the register pair. For example, if I were going to do an 8-bit divide and started off like this. I'm storing 3000 into the AX register. That's going to be our dividend. Then I'm going to divide by 10. That should give me a quotient of 300 that will be stored in the AL register. But the AL register can only hold, at most, 255, and that's for an unsigned number. It'd be even smaller for a signed number. Well, what happens then? The answer is my program crashes with an exception being thrown. Now, the way to avoid this is pretty easy. As I've said a couple of times in this video, the type of division we're going to be doing the most is 32-bit. And the reason is, in a high-level language, 32 bits represents an int. So I think if you just stay with 32-bit division, you will avoid this division overflow. Fairly easy. So there you have it. Integer division using both signed and unsigned data. I definitely think this is easier to understand after having done integer multiplication because of the way register pairs are used in both of them. They're just used in inverse ways. If you have questions about this, please get with me. And thanks for watching.